Trigonometry.
Yes, applications of trigonometry. I have only one application. That application is
Heights and distances.
yes, heights and distances. Okay, one image is given here, right? So we are
Yes.
virtually we are measuring. That is we considered the image of the India gate, right?
Yes, sir.
On the right hand side, you can see the image of India gate. Now, trying to measure the height of this, right?
Yes, sir.
So, what are the things that are given? First of all, you have to identify the objects or the things that are given, right?
Yes.
For applying the trigonometric rules, you know very well, right?
Yes.
Good idea of trigonometric entities, right?
Yes.
Okay, what are those? Can you say anyone?
Sin square theta plus cos square theta is equal to 1.
Okay,
1 plus cot square theta is equal to cosecant square theta.
okay,
1 plus tan square theta is equal to secant square theta. Those three on no.
yeah, you are good at remembering, but I am not, right? I don't remember, but I do construct whenever I need. So that is the different thing. Okay, here it may be whether it is an identity or whatever it is, that is all connected angle, right?
Yes, sir.
Whatever you say, either it is identity or whatever it is trigonometry, it deals with the angles. And the second one is
Sides.
sides are length, right?
Yes.
So these are the two important parameters that we will be looking for. One is the angle, another is the length. So what is the relation between these two, length and angles? This we already discussed, right?
Yes, sir.
Can you remember where exactly we discussed about length and the angles?
Circles, areas,
Do
everywhere.
you remember?
Everywhere we discuss.
Hello?
Yes, sir.
Do you remember?
We discussed in almost every chapter now.
About this length and
Introduction to trigonometry.
this is where we discussed, right?
Yes, sir.
This is the sector length. This is the angle, right?
Yes, sir.
So this is the radius or the line. And another one is the transformations, right?
Yes, sir.
This is called x coordinate and this is called y coordinate, right?
Yes, sir.
This is r, right? So
Yes.
x is equal to r cos theta, right?
Yes.
Y is equal to r sin theta, right? So these are the two equations I got. How I got? Because of the trigonometric ratios, right? From the definition of trigonometric ratios. From the trigonometric ratios, the sin theta is equal to opposite side divided by hypotenuse, right?
Yes, sir.
Similarly, cos theta is equal to adjacent side divided by hypotenuse, right? Am I
Yes,
correct?
sir. Yes, sir.
This is the ratio. These are the ratios that we used in deriving these equations. This distance is called x. This distance is called y. This is called origin. We call it as 0, 0. We denote it. But any other point also can be considered as an origin, right? It doesn't make any difference. So if it is 0, 0, then that will be the easier one to find out. Okay, so this is x and y. We usually denote a point by the coordinates x and y or r and theta. So these are the two ways of representing a point. They both represent the same point, but the difference is x is the distance from origin, right? This is the one.
Yes, sir.
Y is the distance from x-axis up to that point. So x is the distance parallel to the y-axis, whereas x is distance parallel to the x-axis, right? So you
Yes,
have
sir.
to take this one as reference. If I create, if I construct, or if I look at these one, and this is the parallel line, this 4, then I will be getting what shape I will be getting? Definitely I will be getting a rectangle, right? Isn't it?
Yes, sir.
So this is one line, this is one line. I have constructed one parallel line, this is another parallel line. So in total I have a rectangle. So this XY coordinates are also known as rectangular. Why? Because it produces a rectangle, right?
Yes.
Okay, whereas this R and theta, do this produce a rectangle? This R and theta? Verify. This theta will be varying from 0 to, so what is the shape I am getting? If angle is varying from 0 to 360, what is the shape I am getting? What is the shape I am getting?
A rectangle.
Uh-huh. This one,
A circle.
circle. Okay, with this point, this one has the center, this one has the point. Then if I change the angle, definitely I will be producing one circle, isn't it?
Yes, sir.
This is the reason why these are called circular coordinates.
Sir, you are not audible, sir.
Hello. I think internet a bit. Okay, am I audible now?
Sir, your voice is low.
Hello.
Sir, your voice is low.
Is it okay now at least? Hello.
Sir, you are not audible.
Still not audible?
No, sir, you are not audible.
Now?
Yes, sir. Bit better.
Maybe disruption, a little bit disruption. So these are called circular coordinates or polar coordinates, right?
Yes, sir.
Why these are called? Because the shape that I am getting is a circle. These are called rectangular. Why? Because the shape I am getting is a rectangle. So that is the simple thing. Okay. So once you have a triangle, either you can construct a circle or you can construct a rectangle. So which one is easier? That way you can solve the problems. But here we are trying to construct a circle out of this, right?
Yes, sir.
Okay, so how I can construct a circle? Because this is the angle, this is the radius, right?
Yes, sir.
So what about this length and this length? Will they be equal or different? This length and this length. Will they be equal or different?
Yes, sir.
Hello?
Yes, sir.
This line
Sir,
and
your
this.
voice is breaking, sir. I can't hear. Sir, you're not audible.
Okay, now?
Excuse me, sir. You're not audible.
Am I audible now?
Sir, your voice is low, sir.
So even microphone is maximum. Okay, at least now?
Sir, it's still low, sir.
Now?
Low, sir. It's low. I can't hear it clearly.
Okay, that may be. Now?
Yes, sir.
Is it okay now?
Sir, you're not audible.
Hello?
Yes, sir.
Is it okay?
It's okay, sir. Like it's still low, but I can hear.
Hello?
Yes, sir.
Hello?
Sir, you're not audible again.
Now?
No, sir.
Here, your phone is maximum. The maximum microphone also I kept maximum. At least now, is it okay? Hello?
Better, sir, now.
Is it okay now at least?
Yes, sir, it's okay.
Is it okay?
Yes, sir.
So what I am asking is, look at this line, right? And this line. Are they equal? Hello?
Sir, you're not audible, sir.
Am I audible?
Sir, you're not audible.
Still?
Sir, screen share stopped and you're not audible.
Why this is asking once again screen share? Is the screen share
Sir,
not
screen
working?
share stopped and you're not audible, sir.
Screen share stopped. Okay, just okay. Am I audible now?
Yes, sir. Now you're audible.
Okay, so I changed the internet connection. Okay, right. So is the screen share working?
Yes, sir.
Fine. So now look at this. So this is what the principle is. Suppose this is your height, suppose, right? You are viewing this one from this point, right? This is the angle. This is the angle now you are making. This is called line
Yes,
of
sir.
sight, and this is called, okay, how to find out the height?
Sir, your screen share stopped.
Oh, so what happened? Mhm. So is it working now? Hello?
Yes, sir.
Okay.
Tuition.
So I don't know. I don't know whether it's giving some trouble today. Hmm?
Yes, sir.
When oh, this full screen is doing. Oh, is the screen share working?
Yes, sir.
Okay, it is doing because that full screen is giving some trouble. So I'll try. So is it okay now?
Yes, sir.
Okay. So just look at this at different positions. Okay, now just watch what I did. Right?
Yes, sir.
Now the angle is 27.2, right?
Yes, sir.
Okay, now I am moving this one to another point. Yes, now. Is the angle same or is it different? Hello?
Yes, sir.
You got my point?
Yes, sir.
This is one position, right? Here, the angle is 27.2, right?
Yes, sir.
Now I am moving to another position. This is another position. I moved. At this position, is the angle same to this point? Hello?
Sir, you are not audible, sir.
I am asking a question. I am waiting for your answer, but you are not answering.
Yes, sir.
Okay. The point I am asking is, I moved. I kept my observation at this point. I am observing this point from here. Okay.
Yes, sir.
Now I am moving to another point. Right?
Yes,
Here.
sir.
Here, when I am here and looking at this point, the angle is 27.2 degree. Right?
Yes, sir. Angle of elevation.
Right. Now I am moving to another point. This is the point. Is the angle same?
Yes, sir. It will be the same.
Sure?
Yes, sir.
Sure? How? And how you can say that the angles are the same? What made you to conclude that?
Sir, because
Mhm.
I just
Because?
guessed, sir. I just guessed.
Yes, sir.
Yes, sir.
Why you are guessing? Mhm. Okay, let us check.
Yes, sir.
What is
Oh,
that?
it's different. 32.9, 40.
So will it be same?
No, sir.
No, because very simple. Suppose you are observing one object, and if you move closer to that object, you lift your head or you keep your head down.
I lift head.
Why?
Sir, because it gets bigger.
Means elevation angle increases, isn't it?
Yes, sir.
That's what it happened here also. Okay. So
Yes,
as we move closer to the object,
Yes, sir.
if I want to find out the height of bigger and bigger and bigger objects, right? Then what should I do? I need to move far away from it, right? So that
Yes, sir.
I can have very less angle. It will be difficult to have a bigger angles. So I
Yes, sir.
try to minimize it. That is the method that we are adopting now, right?
Yes,
So
sir.
when this is the position, you can move this angle. How this activity works, I will show you. You can keep this at different heights, right?
Yes,
This is
sir.
from ground, right? Okay, this is from ground. From ground, it is at height 2 units. Okay, this is at some other height. This is at some other height. This is at some other height. This height also very important, right?
Yes,
That's
sir.
what I am showing now. Previously it was here. Now I reduced this one. Will the angle increase or decrease? The same.
Increase, sir.
Okay, so we verify, right?
Yes, sir.
I keep this one. Okay, what is the angle now? 32.8, right?
Yes, sir.
Okay. Here it is how much?
29, sir.
What happens if I decrease this height?
And
Definitely angle
increases.
increases, right? So as I increase this height, this angle of elevation definitely decreases. Suppose I take it up to that height. Let me verify. Is it right?
Yes, sir.
Now, this is the observation you can make with respect to height, right? With respect to height, how this elevation angle is getting changed. So this elevation angle, right?
Yes, sir.
So if you observe and make a tabular column for one, this height and angle of elevation, then it will be easier for you to predict, right?
Yes,
So at
sir.
some height from the ground, suppose it is kept at 1 unit. Suppose this is kept at 1 unit. Instead of 2, I keep this one at suppose 1 unit. Horizontally, I am not changing, right? Only vertically I am changing. Now this is the angle. If it is from the ground, so this is the angle 38.2. So as we move above the ground, definitely angle of elevation decreases, right? You got the idea? One observation?
Yes, sir.
Okay.
Yes, sir.
So horizontally, if I move closer, suppose height is same. If I move closer, definitely the angle of elevation once again increases, right?
Yes, sir.
So these are the two observations you must note down. For the first observation, you make a table, right? Height, angle of elevation, right?
Yes, sir.
Horizontal distance. This is called a line of sight. Horizontal distance and angle of elevation, right? So these are the two
Yes,
things.
sir.
You make 10 observations. Means 10 distances. Suppose you start with this is the one, two, right? So exactly along this horizontal, this line. Okay, you move this one
Yes, sir.
along this line. So keep it at 3, note down the angle. Move to 4, note down the angle. Move to 5, note down the angle.
Yes, sir.
Like this, you have to complete the activity. Okay.
Yes, sir.
So at 10 different positions, you note down the distance and angle of elevation, both. And then you can derive the relation between the two, and then you can find out even the trigonometric ratios only from
Yes,
that
sir.
tabular column, right? I am not showing everything. Why I am showing you this? Because you have to do and complete the activity, right? Then you can see whether your understanding is improved or not. If everything is done by myself, you will become passive enough, right?
Yes, sir.
Okay. So you are becoming passive, that I don't want to. That's the one. Okay. So take this one as one activity. The same thing. Yes. How this actually, that formula or whatever it is, and what exactly that method works and everything is given in this one, right?
Yes, sir.
Simple thing. What is the formula? We are using it. Tan. Trigonometric ratio tan. So this is the angle. So every time you will get one new problem. Get hints. right?
Yes,
If
sir.
you are unable to solve it, you click on get hints, right? Okay,
Yes, sir.
got
Okay,
it?
sir. Yes, sir.
You will get the score if you find the correct one, right?
Yes, sir.
So you can practice. This is for your practice. That is the formula or whatever it is. So try to find out directly from the first activity, and then you directly predict what may be it without finding or using the formulas, right?
Yes, sir.
Okay, you try to prepare the tables. From the table, you can find out if it is 60° and this is 50 and what is the value of that height, right?
Yes, sir.
So better prepare the table from the first activity for different values. From that, you can project it to any distance, right?
Yes, sir.
Okay, that I am giving you as an assignment and try to complete it. This
Yes,
is
sir.
the regular practice. Just get a new problem and then use the formula. Instead of using the formula, try to find out by prediction using the tables that you prepared from the first activity, right? If
Yes,
you are
sir.
not good at, definitely then try with the formula. Why? Because you need to find out the tan values. Can you calculate tan 60? You
Yes,
know the
sir.
values? Tan 60, how much?
Um, uh, one, I think, sir.
Tan 60.
60.
Tan 90 is how much?
I need to got tables.
Oh, then, so how to remember those ratios?
I can write the whole table, sir.
Okay, what is tan 60?
1 second.
Okay. What are you preparing?
Um, Sine 30 and
Mm-hmm.
by cos 31.
Sin 60 by
Root
cos
3 will come, sir.
sin 60 by cos 60.
Cos 60. Yes, sir. I got root 3.
Okay. Tan 45.
Tan 45 1 by root 2 by 1 by root 2, which will be 1, sir.
Okay. Tan 90.
Tan 90 is undefined
Mm-hmm.
or infinite.
Anything. Right.
Yes, sir.
Okay. Tan 0.
Tan 0 is 0 only, sir.
0 only.
0 by
So
1 is
tan
0,
value
1 by
is
0 is undefined.
tan is maximum when?
Tan 16.
Okay. How to remember that? Do you need to by heart them or is there any other way?
Sir, first I write down sign, sir.
Uh-huh.
Sign I know. Only
Mhm.
sign I learned, sir. So sign I will write down. Next
Mhm.
sign reverse form cos will be no, sir.
Mm-hmm.
I write sin and cos down. Then I divide sin by cos to get the tan values, sir.
Mm.
Then sin inverse is cosecant, cos inverse is secant, and cot inverse is tan.
Mm-hmm.
Like that, I finish the table and then I do all the sums related to
Mm-hmm.
trigonometry.
Okay. Or to remember. Do you need to by heart them or you have any other method?
Like what, sir?
That ratios.
Sin I remember, sir. That's it. Only sin I'll remember.
How you remember? That's what I'm asking.
I just buttified sin, sir.
Okay.
0, 1 by 2, 1 by root 2, root 3 by 2, and 1.
So fully mugged up.
Only that one, sir.
Mm-hmm. Okay. So can you okay? Look at the graph, right?
Yes, sir.
Mm-hmm. Okay.
Yes, sir. All.
So instead of this one, you take the radians. Okay. So what is the maximum value? What is the maximum value of this height? What is the maximum value? 1, isn't it? Hello?
Yes, sir.
What is the maximum value? 1.
Yes, sir.
What is the minimum value?
0.
Mhm.
-3.
Minimum, how much?
-3.
How much? How much it is? Hello?
Yes, sir.
How much?
-1.
Yeah, +1 is maximum, -1 is the minimum.
Yes,
It
sir.
can't go beyond -1 or +1, right?
Yes, sir.
This is the maximum. It can't go. Sign value cannot go beyond +1 or less than -1. It will be in between -1 and +1 always. Okay. So this is the simplest graph you can remember, and then you can say, okay, when it will be 0.5,
Yes, sir.
when it will be 1, right?
Yes, sir.
This will be how much? This is 0.5. At what value of 0.5 is at what value? Okay, so 0.62, 64, 68, 0.64 in 72, 76, 0.8. So 0.64 it is. So if you
Yes.
want, you can zoom it and then you can see, right? How much it is? 0.62, right?
Yes, sir.
This one is, how much is this? 0.6. Okay, 0.5. You can find out at 0.51, 0.38, right? 0.1 is at 0.1. 0.1 of 0.1 radians, not the degrees. Don't confuse it, right? Okay, 0.1 radians means how much? How much in degrees? 0.1 radian. 1 radian is, hello? 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 Hello?
Sir, am I audible?
Yes, you are.
Yes, sir.
Okay. Are you able to see it?
Yes, sir.
Mm-hmm. Okay. Now you look at this. Along horizontal, this is the radians, right?
Yes, sir.
3.14 radians means what? How much? In degrees. 3.14 radians is equal to how many degrees? You remember? Hello? 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 Hello?
Sir,
Yes.
audible?
3 point. Am I audible? Is it okay?
Sir.
So, am I audible?
Yes, sir. But your voice is low.
Is it okay now?
Yes, sir.
So, 3.14 radians is equal to how many radians? How many degrees? You remember it?
Yes, sir.
Yes, tell me.
Pi by 2.
3.14.
Yes, sir.
3.14. What is the pi value?
3.14, no, sir.
Then how you say that 3.14 radians
22
is
by 7.
3.14 radians is nothing but pi by 2 radians, right?
Yes, sir.
Sorry, pi radians. 2 pi is 6.28, right?
Yes, sir.
Pi is 3.14. That is nothing but pi radians. Pi
Yes,
radians
sir.
is equal to 180 degrees, right?
Yes, sir.
Okay, this is 180 degrees. This is 180 degrees. Total 360 degrees. This is getting one circle. Is it correct? Exactly true or not?
Yes, sir.
Okay, how you know that one, that it is giving the same a circle, right? That you can easily understand. I demonstrated in the beginning, but you might have forgot. I will show you once again, right? So 3.14 minus 3.14 to 3.14. This is one cycle, complete one cycle, 360 degrees and 2 pi radians. Or I can say 360 degrees, 180 degrees, and this is 180 degrees, right? Plus 180 minus 180, total 360. So from this one, what is pi by 2? Pi by 2 is how much? 3.14 divided by 2, right?
Yes, sir.
3.14 divided by 2 is how much? Quickly, 3.14 divided by 2. How much it is?
3.14 divided by 2.
Oh, 1.6.
1 minute, sir.
1.67.
1 minute, sir. Let me verify. Yes, sir. 1.67. Yes.
Okay, 1.67. Where is that one? 1.67. This is 1 point, right?
Yes, sir. Somewhere between one.
Now I
More
got
we need, sir. More we need to go. 1.67, sir.
62, 64, 66. This is around 68.
Yes.
Ah. You got it?
Yes, sir.
1.7. This one, right?
Yes, sir.
Here it is, right?
Yes, sir.
Okay. So here it is. This is how much you can find out. How much this is at this point? This is almost 0.9 or so, right?
Yes, sir.
So you can find out. So this is almost 1, right?
Yes, sir.
This is the maximum value, 1.6. If I still zoom it, what is the value? You can see, right? 1.6. Are you getting? Are you able to see it or not? 1.65, 67, right? Right?
Yes, sir.
So you can zoom and see the values, right? So here
Yes,
also
sir.
the same thing. You can see both, right?
Yes, sir.
Height and this one. You can see it. You can zoom and then you can verify that is exactly maximum or not. So sign. Suppose if I have the tan value, how do I get? What is the value of this tan? So similarly, if I go with minus 3.14 less than x less than 3.14, right? Oh, beautiful shape I got. Okay. How does it look? Hello?
Yes, sir.
How does it look?
Like a bird.
Yes. So you got the idea how you can make the birds with the help
Yes,
of
sir.
sine curves and tan curves, right?
Yes, sir.
Okay. So you have two birds opposite to one. So this is the shape. This is the one you have. This is one curve, right? This is the one. So this is where x sine and tan overlap. This is the region, right?
Yes, sir.
So within this one, sine and tan both are equal, right? Here this is the maximum, but at the same this point, at this point, this is almost infinite, right?
Yes, sir.
This one, right?
Yes, sir.
So this is the infinite one. Now you can see. This is the infinite. When this is maximum, this is becoming infinite value, right? So you can observe these overlapping regions, right?
Yes, sir.
This is the overlapping region in between which values sine and tan will equal. Similarly, what about the cos value? Cos of x, how does it look, right? And if I restrict this one, minus 3.14 less than x less than 3.14, this will be looking like this. Oh, sorry, yes, less than. Right?
Yes, sir.
I remove this one so that it will be clear for you. So the difference between sine and cosine, sine and cos, you can see the difference between sine and cos, right? This
Yes,
is the
sir.
difference. How much when they will be equal, right? At this point,
Yes,
these
sir.
are equal. What is the value of that along x at which particular value they are equal? You can verify 0.6264, sorry, 64, at which value they are equal? 0.78, right?
Yes, sir. Approximately.
7576. Okay, you can zoom and find out. 76782, right?
Yes, sir.
782, 782. You want, you can zoom it and then you can
Give a
exactly
more
0
precision, sir.
point, yeah, more precision is
785.
785. It's also not 784, 7855, right? Isn't
Yes,
it?
sir.
7855. 0.7855, that convert into degrees and then you will get the value, right? So
Yes, sir.
this graphing tool is not that much precision that you can understand, right? Whether it is.
Yes, sir.
So can you convert quickly? Can you convert 0.7855 into angles? Can you convert 0.7855 into degrees? Can you
Yes,
convert
sir.
quickly?
Yes, sir.
How much? 0.7855.
Sir, approximately it will become 0.786.
This is in radians. I am asking in angle, that is in degrees. This is in radians. Can you quickly convert this one into that angle in degrees? That's what I am asking.
Yes, sir.
How much it is? 0.7855 radians is equal to how many degrees? It seems you require a calculator.
Yes, sir. I'm not that great in mental calculation.
You might have become, but still,
Better, but not great, sir. Basic addition,
okay.
subtraction, I'm able
So
to do.
improvement is there. That's what we are looking for, isn't it?
Yes, sir.
So improvement, gradual improvement is always the best thing, right? So slow and steady, that is the one.
Yes, sir.
Okay. Still practice. If you really practice all the things that I am showing, then it will become better. How to quickly calculate? That's what. 0.7855. Okay. How you convert it? Any simpler methods of multiplication or the divisions, right? That requires simpler methods
Yes,
of
sir.
multiplication and division. I will show you one or two methods so that you can calculate them very quickly, right?
Yes, sir.
Because this is 5 at the end, that will be easy for you to calculate, ending with 5. Okay, what is 1 radian? 1 radian is equal to how many degrees? 1 rad.
180.
Radian is equal to 1 radian is equal to how many degrees? Oh, 3.14
Yes, sir. 5
divided
degree.
by,
180.
isn't it?
Yes, sir. I forgot the 3.1.
Yeah. Sorry, 3.14 radian is equal 180 by 3.14. Sorry, 180 by 3.14.
3.14.
This is the one. First, you calculate how much it is. 180 by 3.14. This is 1 radian.
Yes.
If you know this one, then that will be easy for you to calculate, right? 1 radian is equal to 180 by 3.14. How much it is? 180 by 3.14. Roughly you calculate. Rough calculation. Consider this one as 3 only, right? we make an approximation. 180 by 3, how much? Hello? Hello? Hello?
Start doing the 1 minute. Sir, I got 57.32. Sir, you are not audible again.
Okay, calculated?
Yes, sir. 57.32.
Right, that is good. Okay. 50?
Yes, sir.
57.
0.32.
This is 180 by 3, right?
Yes, sir.
Okay, now 180 by 3.14. It should be less or more than 57.32. So I consider 57, right? Because
Yes,
it's
sir.
less than 57.32. I remove 0.32. I consider this one as 57 degrees, right?
Yes, sir.
Okay. Is it true or not? That you can verify.
Yes. Pattern is nice though.
This one?
Yes, sir.
Okay. This is good. Okay. At 1. Right?
Yes, sir.
57. You can find out. Right?
Yes, sir.
So 57. So how much it will be? 0.78. 57 into 0.7855. Right? So I make it approximately 0.8. 57 multiplied by 0.8. How much it is? 57 multiplied by 0.8. 8 divided by 10. Right?
Yes, sir.
Okay. How much it is?
57 into 8 by 10. 1 minute, sir.
456 divided by 10. Right?
45.6.
Yes. So 45. So am I getting 45 degrees or not?
Yes, sir.
Okay. At 45 degree, what is the value?
45.
Both sine and cos are equal, right?
Yes, sir.
Okay. When
Both
do
are
they
one.
equal? Yes. At 45 degree, they are equal. Is it what you got from your ratios or not?
Yes, sir.
Sine 45 is equal to how much?
1.
Sine 45.
1 by root 2.
Cos 45.
1 by root 2.
Both are same, right?
Yes, sir.
Okay. Cos 1 by root 2. 1 by root 2 is how much?
Sine 60. Sine 45 and cos 45.
Value of 1 by root 2. That's what I am asking. 1 divided by root 2 is how much? 1.414, right?
Yes, sir.
Okay, how much it is approximately? 1 divided by 1.414. It seems you need a bit of calculations, right?
Yes, sir.
So it needs to improve. There is a need of improvement in calculations. It requires. Okay.
Yes, sir.
So you need to be a bit quicker in doing these calculations, right?
Yes, sir.
Okay, I will show you. One day I will show you the different methods. or simpler calculations, and without using even the calculators, you can do it. Otherwise, what we can offer is we have our calculator, right?
Yes, sir.
Okay, how much it is? 1 divided by 1.414, right?
Yes, sir.
Got the value 0.714, right?
Yes, sir.
Okay, 0.714. Now you can see from this 0.7, right?
Yes, sir.
Look at this. Look at this value 0.71, right? That's not right. Okay.
Yes, sir.
This is the value 0.7, because we approximated a bit.
Yes,
This
sir.
value is 0.7055, right? Exactly. Got it?
Yes, sir.
So if you know the pattern or the shape is very easy to remember, isn't it?
Yes,
The
sir.
maximum is 1. And if you perfectly draw in terms of the angles, now I am drawing this in terms of the radians. It is somewhat difficult for you to, because you are habituated of using degrees than this one, right? So I will show you how you can replace this one with the pi values. Instead of 1, 2, 3, you can straight away write down pi values, right?
Yes, sir.
Okay, sine curves with pi, 2 pi and 3, etc. Right? That's, you can consider the ranges in pi values. So 0.5 and everything, that setting is also there. That I am giving you this one as your exploration. I don't want to show everything, right? Because
Yes, sir.
still now, I think you are not still not using or did you try this tool? Have you tried
Yes,
this tool?
sir. Yes, sir.
You tried?
Yes, sir, but only to plot the points.
You tried?
Yes,
Only?
sir.
You tried only the
Point plotting.
point?
Plotting.
This tool?
Yes, sir. This tool only just for points.
Just for points. Okay. How you made the points? With the tabular
X
column?
is equal to this.
X equal to?
Equal to coordinates, I will say.
You made the points like this.
Yes, sir.
2, 3, right?
Yes, sir.
This way? This way you made the points. So there is another way. You can use the tables.
Yes, sir.
Okay, now there is another one. Okay, very nice. Stickers. Okay, time is also given. So time variation is given. Okay, I can demonstrate that one. Beautiful. So fine. Then you can create the tables, right? Table of values. 1, 1, 2, 2 to get a straight line. 3, 3. You will get a straight line for this, right? So if I have
Yes, sir.
0, 0 also, I can have, right? This is the line. To connect that one, I have this line, and there is option of 0 less than x less than 4 then 3, right?
Yes, sir.
Exactly. So you try this one. Okay, you construct some triangles with the help of these lines. right? You could draw a vertical line. From here, you try to draw a vertical line. How do I draw a vertical line? From this point, vertical line, how do I draw? X equal to 1, if I write x equal to 2, x equal to 1, right?
Yes, sir.
Okay, but I have to restrict it. So 0 less than x less than 1. If I take, it will come like this. X equal to 1, right?
Yes, sir.
Uh, y is equal to 2. If I take, I will be getting horizontal line, right? So x is equal to 1. Have to
Yes,
restrict it. How you can restrict? Less than y. You can say 1, right?
yes, sir.
So this is one line. This is another line. This is another line you can draw. If I want to draw a line from here to here, how can I write? Y is equal to 0. Okay. I have to restrict this one. 0 less than x less than 1, right? You got it?
Yes, sir.
So this is one line. This is one line. This is one line. So if you try to draw these different objects with the help of simple equations, then you can understand the importance of the relations, equations and everything, right?
Yes, sir.
Have you tried? Have you tried or not? You haven't tried it, right?
Yes, sir.
So this is the one I need.
Wow, sir.
Hmm?
That's of geometric.
Yes, this is letter S. This is letter H. This is this small circle, right? Dot.
Yes, sir.
And it is filled. Okay, that is filled. You can see, right? Hello.
Yes, sir.
Okay,
Wow.
this is the one.
Yes, sir.
So this is a simplest rocket. This is the rocket body. This is made up of these equations, right? You can see.
Yes, sir.
Okay, you can create. So I decorated.
Wow, sir.
This is fish
Yes, sir.
decoration, I used the quadratic equations, sine functions, right? You can
Yes,
see.
sir.
So I used the sine functions. Which one? You can see, right?
Yes, sir.
This is where I used the sine function, right? So you
Yes,
have
sir.
to think, you have to think. Art is also mathematics. You can see how beautiful that one is, right? There are
Yes, sir.
plenty. This, okay, this I think I showed is the one.
Sir, you showed these also.
This one, right?
Yes, sir.
So we have gradient of a curve, right? This is the one. Gradient of a line. Gradient of a curve. Then you can see how beautifully this is done. As you change. So what is the gradient? How it gets changed? Hello?
Yes,
Hello?
sir.
Yo, am I audible?
Yes, sir, but your screen share stopped.
Yeah, it got disconnected and then reconnected. I'm just. Mhm.
Yes, sir.
Right?
Yes, sir.
Not this one. Gradients. Yes. So this is the line. This is the slope variation. How slope changes for the line. But it is for you to use such tools, right?
Yes,
Okay,
sir.
anyhow, if you practice them, why I am focusing once again on those tools is if you practice of using them, your mathematics will and become easier, and then you can easily understand the trigonometrics and what is the method of this trigonometry applying, what is the angle, what the relations, everything you can easily understand. Instead of by hearting, if you remember the patterns, that will be easy for you to understand, right? Okay, at least you start using those tools, right? So did I share that link with you? I think right?
Yes, sir.
Did I share
No, sir.
this link of this tool?
You shared this, sir. You shared this one. Sorry.
Yeah, I think I shared this one, right?
Yes, sir. I had to check.
The thing is, so you try to use it, right?
Yes, sir.
So I think I will be quickly closing this today's session.
Yes, sir.
So tomorrow I will be moving to
Yes.
this one is
Sir, tomorrow is Saturday.
why?
It's festival, Holy, no, sir.
Tomorrow is holy. Okay, fine. So
Saturday.
be there. Hello.
Yes, sir.
Okay, so we meet on Saturday and then we
Yes, sir.
complete that chemistry, total chemistry we discuss, and then